So this is day 2. This is day 3. Day 3 will be tomorrow. If you're wondering where day 1 went, here's day 1. We actually did 13-2 day 1 last Wednesday. Then we jumped to chapter 14 for 2 days. Now we're back to chapter 13-2 day 2. Okay? And day 3 is tomorrow, by the way. Okay, so let me see what the pen was. No. Okay. All right, here we go. So these are, again, your I can statements, but here's the deal. There's the first thing you're going to talk about. Draw me an angle in what form? Standard position. So come back to this stuff. Come back here after we're done. Read it. I can tell you right now, I think this is the dividing line today, where this is day 1, this is day 2. Just read it, come back and read it. See if you can do all those. All right? So here we go. If you listened last week, I did tell you what standard position was, but you probably didn't hear me or whatever. What is standard position? An angle in standard position will look like that over there. It is formed by rotating a ray from the x-axis about its endpoint. Here's the deal. Because we go past 90, past 180, past 360, we just keep making circles to make our angles. Your angle will always start on the x-axis. It will always go this direction, and that's the first ray of your angle. So you always start where? On the x-axis. It is called the initial ray. Or I could say initial side. And to me, that's just your starting point. You go start there, and then you start going up, forming an angle, and the angle just keeps turning around the circle. That's all it does. And as you go around, you should know certain spots. Like that spot is, okay, keep going.
180. Would it be 90?
Yeah, well, it's 90, 180,
270.
270,
360.
and 360. So if you could stand here and jump and spin in the air around right here, you just made a 360. You did a 360. Huh? I'd rather have one of you demonstrate than me.
Can you do it?
Because I fall over that
I can
stool.
do it.
Okay, I'll do
Guys, can you try it? I can do it.
You can do it, Tyler?
Yeah.
A 360? Really? Okay, come on.
What do we need to do?
Get up here. Let's go.
Okay.
Rick, come on, Tyler. Come on, Tyler. Come on, let's see a 360.
No, you have to.
Face it around.
Yeah, what am I doing?
On your hands, Tyler.
Do a backflip.
That's you. Looking at the crowd. You just said you can do a 360 turn. Up, in a circle, stick it. That's a 10.0, by the way.
Oh,
That wasn't bad.
so close.
That wasn't bad. Adrian, did you get that?
Yes, I did.
Nice.
I do.
I got it
You did
too.
that pretty good. Although I can't give you a 10.0.
It's
I didn't stick the landing.
the Olympics, they don't see the landing, they're like crying themselves by the time they're done.
They what?
They like miss the landing, they're like,
Well, they got it. They got it.
I'm not in the Olympics.
Yes, sir.
Are you recording?
I'm recording. Okay.
All right, yeah.
Tyler?
I want you to.
Tyler, pretty good. 360 is not easy. And to not fall down. Okay.
Well, I almost stopped.
I know you did. Okay.
I was
All right.
trying too hard.
Now, hang on. Listen.
Yeah.
You will go around the circle, but you will end somewhere. And if you end, let's say right here, this side is known as the terminal side. So wherever you finish, this is the terminal side. Okay? So your angle could look like this, from here to here. About what do you think that is? I'll give you a number.
210.
210? 220?
215.
Now that's you estimating. You're just estimating the angle. That's good. At least you didn't say 120. Or you didn't say 340, because it's not. It's past 180. You know it's past 180. You should also know it's just shy of 270. Okay, so you're in the 220 range. Okay.
The triangle don't use like the ends.
Well, wait, don't jump ahead. I'm just trying to get what is an angle. An angle is the terminal side You start moving around the circle, wherever you land, that's the terminal side. And then you say 90, 180, a little more, maybe 200, something like that.
So if you land on the same side as the initial slice, it's still called the terminal side.
Yep. So what you're saying is, I think, you're saying what if the terminal side lands right there? Now this is a what angle am I talking about right here?
360.
It's a 360, or it could be called a 0.
What if I went 8 degrees up?
8 degrees would do
Then you lose.
not much. Okay, so let's keep going. This word, I'll get to that later, not now. Okay, let's go here. The measure of an angle is considered what?
Positive.
Positive. When the rotation from the initial side to the terminal side is in what direction? Counterclockwise. By the way, oh, thank you. Okay, positive is this way, counterclockwise. Okay, that's positive. When you get a negative angle, you're going to go the other direction. Which way? Clockwise. You follow the clock, okay? And by the way, your answer is going to be negative 200 degrees, something like that. Okay, now that you know that, go here and see this is on your quiz. This is how your quiz starts. Give me a 100-degree angle. You gotta draw it. So this is your initial side. This is where you start. And 100 degrees, I'm hoping you rotate counterclockwise. How far have I gone right now? 90. I got to go how much more? Maybe a little more, right? So I'd probably quit right there, and I draw my terminal side right here. So there's your terminal side. Okay, so if that's terminal, and that's initial, I've got it, except you got to tell the teacher you truly understand that that's 100 degrees. See, here's what happens on the test. Some students draw it like this. Some students draw it like this. Some students even draw it like this. They call that 100 degrees. I got to know you know this. What I need to know. You need to tell me this angle right here, right there. How much past 90 did you go? 10. You need to tell me 10. Or you could tell me this side, how short of 180 are you?
70.
No, 80. So either you tell me an 80 on the left of that terminal side, or you tell me 10 in between the y-axis and the terminal side. You got to give me one or the other. You don't have to give me both, okay? Any question? What about the next one? What do you notice?
Negative.
It is negative. Draw it. How far have I gone?
180.
Yeah, actually I've gone negative 180. I still got to go to negative 215. So I know I got to go past this, where I can guess right there. I can call that my answer. But the only reason I will give you credit on the test is because you slipped in a number right here. How far past 180 did you go?
25.
25 would get you the wrong answer.
35.
35 is right, yes. Okay, you did not have to give me that one. If you wanted to, you could have given me this one. That would have been,
Does it have to be written as negative?
what now?
Does that have to be say negative 35?
No, this, you know what this little arrow tells me? That arrow tells me you went the correct direction. All I care about is, just tell me how far past 180 or how short of 270 are you?
If we did put negative, would it be wrong?
Where do you want negative?
If I put negative 35, would it be wrong?
If you put negative 35, you should probably go something like this to tell me you're going the negative direction. I don't really, see, to me, the angle's right here. The angle, you're telling me you went this direction. You're just 35 past 180. The only two things I'm looking for is this. Did you go this way? Or did you go this way? And if you went the wrong way, it's wrong. That little stuff inside there, I wouldn't count it wrong, just so you know, but I don't, it's not wrong.
Okay.
270 is an easy one, I think. Right? Which way did you go?
Counterclockwise.
Counterclockwise. How far is this right here? 90. 180.
270.
270. Guess what? You landed right on the y-axis. I don't need to be told. I know if you say it hits the y-axis, it's 270. If you want to stick a 90 in here, I'm 90 degrees short of a circle, fine. I just don't need it. If you land on the x or the y-axis with your terminal side, I don't need numbers. Okay? Good? Draw an angle is pretty simple. Negative is clockwise. Positive is counterclockwise. Okay? We're moving on, right? Okay. Oh, sorry. Okay, go back here. This is page 2 of 13.2. You are supposed to do the same thing. Except this time, they drew the angle for you. And you're supposed to look at it and say, oh, that is 120 degrees. Okay? So find the measure of the angle. But here's the thing. They actually told you that the terminal side went through this point, -2, -2. And now you've got to start thinking back to your special triangles. On a 45-45, the legs are what? Same, XX. Hypotenuse, whatever the leg is, times square root of 2. What about a 30, 60, 90? Here's your 30, 60. If your short side is x, what's your long side? X square root of 3, and the hypotenuse is always 2x. Okay? Good? Now look at this. To me, you see that little dot there? I'm going to extend my dot further out because I just don't have much room to work here. I'll be right here. Okay? So there's my terminal side. So this tells me I don't see a triangle, but I can put one in by just going from the dot, or the point, straight to the x-axis, back to the origin, back to the point. Just keep making this triangle. And now you do know the legs. The legs are going to be -2 for x. Y is -2. So guys, if you're looking at that triangle, it's a 2-2. Legs are the same. It's a 45-45. You should be thinking, oh, this is a 45-45. Put a 45 here. You can put one down here if you want, but I'm not going to. And then start asking yourself, what kind of angle is this? Well, it's 45 past 180.
2G.
It's what?
2/3.
200, well, it's 180 plus this 45, right? So that would be what? Right? 225? Okay. You have to look at the information they're giving you. They're giving you the x value, the x, and the y value of your legs. Then look over here and go, which triangle is it? Of course, if it's a 45, well, that's nice. Add 45 to 180, you got it. That one over there, B, this one's really nice. This one points right at the y-axis. So you're going, how far? -90. -180. Yeah, this one, there's very little to do. Just follow the direction, it's negative. Count by 90s, you end up at 270. Good? There's not much to do on B. Okay? Then you go to C. I'm going to extend this a little further out again. Put my dot up here. Now to get your triangle, you want to go down to the x-axis, back to the origin, back to the point. Just keep, there's your triangle right there. Question is, what are your legs?
1 and 3.
Is that a 1?
Negative.
Okay. Is that, and that's a square root of 3?
Square
Okay. Now you have to look and say 1 square root of 3. There's a 1 in front, by the way. Well, look. If this is x, then this is
69.
x times square root. Which one's the short leg?
-1.
-1. This is the short leg, which means this is what angle?
30.
Yeah, what's opposite the short leg? 30. This is 30. This is what? 60. Now you should be looking going, okay, this is going to be how far from here to here? 90. But if I kept going all the way to here, how far is that? 180. And I'm short of 180 by how much? 60. So I personally would have done this. I'm short of half a circle by 60 degrees. Answer? 120. But there's other people that don't do it that way. Some other people go like this. Could I have thought of it like this? 90 plus this piece? What's that piece? 30. So some people think of it like this and get the 120. Doesn't matter. It's just that I base everything off of 180. I always think to myself, I'm short of 180 by a little bit, or I'm over 180 by a little bit. I always think 180. You might think differently and try it your way. Should work either way you do it. Good? Next. I can't see these numbers, so you're going to have to help me. I'm going to put my point here. So here's my triangle from the point where? Go to the x-axis, back to the origin, down to the point. X-axis, origin, point. There's your right. Question is, what's this leg? Look at your paper, not this. I can't read it.
Negative square root of 3 divided by 2.
Okay, and really that number is negative 1/2 times the square root of 3. This side is what? Negative 1/2. So you should be thinking, oh, the short side, here's the short side times the square root of 3. So if this is the short side, this is what? 30. This is your 60. Okay? Well, they want the angle. What did you guys put? Negative. You went negative, didn't you? Yeah. Because they went this way, didn't they? They're going like this. And again, I always think from here to here is negative 180. Okay? But guess what? I'm short by how much? 30 short. So I'm going to add 30 because I'm going back in the positive direction. That gives me negative 150. Now some people don't do it that way. Some people go like this. Negative 90. And then what would this be right here? Negative 60. Which would also get you negative 150. So either way you do it, you do get the right answer. Okay? Good? You gotta know. You have to know this stuff right here. Short side, long side. 45, 45. You gotta know that stuff. Okay? Otherwise, this is really, really difficult. Okay. I'm almost done. This is the last piece. The last piece will be what are coterminal angles. What are they? I'll read you the definition and then I'll just show you a quick example. Coterminal angles have the same what?
Terminal side.
Terminal side. So right here. Same terminal side. Two angles are coterminal if they differ by multiples of 360. Hello, Ms. Baker.
I wish.
Okay. Can I keep her for about just 3 minutes? Okay, thanks. Bye. Maddie, go see your counselor in 3 minutes. Okay. What is coterminal? Coterminal is this. Okay. See this? I'm going to make this up. 60 degrees. So that is a 60-degree angle. Coterminal means give me another measure of an angle that lands in the same spot. This is called the terminal side. I need another one. Another angle that is not 60, but it looks just like a 60. Well, if you took your pencil and went 60 plus another circle, what would that be?
360.
60 plus another circle, 420?
Yeah.
Okay. 420 and a 60 are exactly the same look. If I said graph me a 420, you'd end up just like a 60. Okay, could I add another circle? Could I keep going? Wouldn't that be 780? So a 780, a 420, a 60 are all the same. Does that make sense?
So
Okay.
they're all the same.
They're all the same. If you drew them over and over, you just get the same spot, same terminal side.
It would be the same for -2.
Yeah, now let's talk negative. If I went this direction, okay, watch. Here's a 60, but could I have just done this? Here's the terminal side. Could I have went this direction? So 60, take away a circle. Wouldn't this also be the same? A -300 is the exact same as a 60. So is a 420, so is a 780. So how many answers are there? Yeah, it goes on forever. But why do we do this? Because when I start giving you angles, like big angles, then you always want your angles to get smaller and smaller until you get between what two numbers? 0 and 360. I want all your answers between 0 and 360. So now, go find a coterminal angle to whatever that first one is. Is it this one? Yeah, 395. So if you're ever given a 395, don't ever work with 395. Get it between 0 and 360.
Just keep subtracting 360.
Exactly. Keep subtracting or adding.
35.
In this case, we want to subtract. Answer is 35. Okay? That is such an easy number to work with versus a 395. Now, a -250. I don't like it because it's negative. So either add a circle or subtract a circle. You probably have to add a circle to get to positive. And, whoops. Answer is 110. Okay. So a 110 and a -250 are identical angles. You can draw them on your own, just check it out. It is. It's going to work. So if you ever want to get a coterminal, add a circle, subtract a circle, which is 360 either way. Okay? All right, last question. It says, which of the following four angles is what? Is not coterminal. So three of them are, one of them is. Think about it. Think about it. Okay, you know which one I like? Out of the four, which one do you like?
40.
Okay, 45 is pretty easy, right? Okay, get that one to be between 0 and 360. Once you just subtract it, subtract a circle, you'd end up where? 45. So these are coterminal. Well, I'm looking for not. That's not good because that's negative. Make it positive by doing what?
Adding 360.
Add a circle. If you add a circle, you get what? 45. Again, same as. So we got coterminal, coterminal, coterminal. You guys should know that 45 is right here. That's a 45. And you should have seen it already that 315 is where? In quadrant 4. Right here. That is a 315. That's not even close to a 45. It's in the wrong quadrant. The answer was D, dog. You do have a new calendar. Right?
Yep.
Okay. I hope you got rid of the old one. It's a book assignment today. I can't remember tomorrow. Tomorrow might be worse.
It's worksheet. I got this weekend.
You got 10 minutes. Get the book open, please. Keep going. Knock out a few. Taylor, you,
Are you coming to work by me?
I'm sorry, not Taylor. I'm sorry. Eric.
No. Are you coming or no?
These scores, confidence in books.
I did everything for you?
You did, for sure.
Working on the paper.
Oh, you know what? You're good. You're good. It was you, Cole. It was you. Okay. Okay. Taylor, sharpen it up. Let's go. Okay. Dan, see you tomorrow.
Quick question. Okay. So sit this on Thursday.
This one? Close. Okay. Find the other 5. Oh, so you got cosecant is 5.2. Okay, 5.2 is 5 and 2/10. Right?
Okay, yeah.
Change 5 and 2/10 to a new property.
Taylor. Yeah.
Can you do that in your head or
This
not?
is the first thing
I can 50, 52.
Why are those ones?
No, reduce it. Shh. Hey guys, go to work. Go to work. Harry, go to work.
52 divided by 2.
26
26
over
over 5.
26 fifths. That's what that says. Cosecant is 26 over 5. Okay, it doesn't say 5.2, it says 26 over 5. What is cosecant? Opposite or hypotenuse, or what is it? How's that go? What is cosecant the reciprocal of?
Is that cosine?
Sine. So can you flip sine in your head?
Yeah.
What is it?
Wouldn't it be 5? Wait, it would be hypotenuse over
Mhm.
opposite.
There you go. So you know that 26 over 5 you told me?
Yeah.
That would be the what side? Hypotenuse over the opposite. So if you
Okay.
draw a triangle, just draw a triangle
Okay.
somewhere. Okay. Put theta in one side. I don't care where you put it. Okay. Cosecant is hypotenuse over opposite.
Yeah.
So this is 26, that's 5. Then to get that side, you have to use Pythagorean theorem
Yeah.
to get it. And once you get that side, then you just always look at theta, because you called that theta.
Mhm.
So what would sine be? 5 over this. What would cosine be? This over this.
Yeah.
Secant, this over this. Right?
Yeah. Okay, that makes sense.
The,
I just
the
didn't know
problem
how to
was
get
when
it.
it was in decimal.
Yeah.
I know.
Okay.
See, that's why I always say trig, the answers to trig, like when you say tangent of theta, is always, it's a ratio, it's this over this. So they were writing ratios for you all over the place, then they switched it on you and they gave you decimals.
Yeah.
And decimals are ratios, you just have to convert them over.
Okay. Thank you.
Yep. So,
He owes me some money.
what's wrong?
He owes me some money.
By the way, you walking around with my shavings of my pencil.
It's not yours.
Here,
Yeah, it's not his.
This one's mine.
that's yours? You walk around with this stuff? Where'd you get this? Where'd you get this?
I don't know. It's in my backpack. But consider it mine. That is mine.
Throw that away.
It's in my backpack.
Where's your book?
It's in there.
What away? Oh.
I shouldn't have to do it.
That's okay.
You can look
You too?
Okay.
How we doing?
Hey,
8:32.
I missed the field biology. I missed
Yeah.
the biology. Student
John, you okay?
What was I gonna do?
Yeah.
Round.
I hope, I hope you didn't mind the whole thing.
The one, who's the one?
We go to that Saturdays.
It's like,
Oh, this morning?
I had her across before, but
Kylie.
I put up an example of flow because she was confused about it. I hope you didn't mind that.
No problem. She learned that. You're okay.
This right here. This right here. Is
Good, good, good. All three of you?
It is.
Will, okay.
that's a new word.
Class measurement is 45.
these are special times, you don't have to do any work, you should probably know. I mean, you know, in a 45 40, you should know this is X. This number, whatever this number is, times squared. So you see this light? That light? The hypotenuse is the leg times square root. So you just took 3 squared. Oh, okay, sorry. I would take 3 square root of 2 over 2 times the square root of 2. Oh, that's what you're doing. No. You just multiply straight across. Okay. If there was an equal sign, it'd be 3 yes plus 2. Okay. So what would this be? It's not square root of 2, it's square root of 2. Six on top.
I did the work first.
And if you go back, so let's say you go back. If you do this, there's a 4 here. You know what you would do.
Then the rest of them are,
It's multiplied by 2. To get
the
your
rest of them are
numbers,
36,
backwards by triangle signs like this. Right? It's multiplied by square root
even
of
me
2.
though.
The bottom you get 2. You're squaring root of 2. Those cancel, you get 2. You got it. You did it. Okay.
On the English version, I'm good, so it means that.
You look like you got it.
Yo!
Questions?
What'd you say? We get to mess around that period.
Oh, yeah.
Are we doing okay back here?
We ain't called that for it the whole time.
At
But
least.
I don't work, I work. No, even if you did work, I still need to know. President Trump defends travel ban. Quote, any negative polls, it's fake news. Well, I mean,
Harry?
it'd be a problem. What?
How much did you get done?
I got to problem 12.
Full assignment.
What did we start on?
7, 20, 4, okay, 4 problems.
You got 4 done?
I have 18.
That's
In 10 minutes?
5. That's pretty good for me.
Is that good?
Yeah, that is. I got problem
It's the only
daily.
day job we-
Did you get that one?
I got so much stuff. I got
10 minutes?
See, I got.
Oh,
Between the 3 of us, I got the most stuff.
You did, Harry. Harry. I don't know if you should be bragging about that. You got 3 done in 10 minutes.
I know. Don't worry.
4 done. And Harry, they were just drawing angles, right?
Oh yeah, it is 5. It's 7. 12 minus 7. I ain't using a calculator. Calculators.